This is the seismic reflection configuration lecture. We will continue talking about configuration. The first one is simple configuration, and this is stratified. You mean you have a lot of like bedding planes. Either you can see parallel uniform deposition of continuous reflections, uh, or something similar to parallel, which is sub-parallel, mostly parallel with small degree of reflector thickening and thinning according to the deposition to the sedimentation degree, and divergent, in which we see the reflectors disappear internally, thin from one side and thick from the other side. Parallel pattern includes subparallel and wavy pattern, as you will see in this figure. Yes, as you can see, some of them parallel, some subparallel, some wavy. And all of those actually they just indicate a uniformly subsiding shelf or stable basin, which is a uniform rate of deposition for those sediments. This is the real section of parallel and subparallel reflection pattern. And the second one is divergent configuration, characterized by wedge-shaped unit. This will indicate directly lateral thickening. We can interpret that as a lateral variation in the rate of deposition or progressive tilting of sedimentary surfaces during deposition. It's very clear that you see this pattern is very thin from one side and is getting thicker from the other side. And this figure shows the lateral variation in rates of deposition or progressive tilting. So this also indicates the environment of a progressive tilting of sedimentary surface during the deposition. Here are some examples of real records. Prograding reflection configuration. This is the third type, and generally we call this cliniforms. Anything that has dipping surfaces generated by strata that were deposited on gently sloping depositional surfaces called cliniform. We have, in this case, we have different patterns like sigmoid, oblique, hammocky, and prograding reflection configuration. The sigmoid one, from its name, is S-shaped. It is S-shaped down lapping character building outward. And whenever you see this blue writing here, means this indicate the indication of what? Indication of fine-grained low energy deposition. Oblique. Also, this is here is indication of what? Indication of sedimentation rates and commonly contains clean sand in the upper portion of the bed form. So this is a very good thing to know. Whenever you have a specific pattern, you just directly express, or you can just guess the environment of deposition. Shingled is a it's a thin interval of top lapping and down lapping. Also here you can, this is an indication of a shallower water depth. And these are some examples of those prograding seismic reflectors: sigmoid, oblique, complex, shingled, hammocky, and complex here means that you have sigmoid plus oblique in one. These are real examples of those seismic sections. Same thing. Chaotic. Chaotic means you don't have a specific pattern. So it is interpreted to represent a disordered arrangement of reflections of the surfaces. And they usually have no continuity with other reflections in the same unit. Okay? And you cannot just recognize a specific like bedding or parallel or subparallel, as you will see here. So, but this is indication of deposition of strata in variable and high energy environment. So once you know it is a chaotic pattern, you just guess directly of high energy environment. This is an example of chaotic or no strata pattern. These are real examples of seismic records for the Cautic. Reflection free, and from its name also it's having no reflections from internal structures, where you can find those in homogeneous layers without any density velocity contrast within the same layer. Also non-stratified unit. So, and this is the last one of those configuration. Here is example of the reflection free, and this pattern may represent homogeneous non-stratified unit such as igneous masses or thick salt deposits. Okay, thank you. And next lecture we will be talking about reflection continuity as an important parameter. Enjoy your time. Bye.